Happy New Year, everyone. Welcome to 2019, the year Beto decides to run for president. Woo! Let's do this. Yeah. He's going to decide.
Oh, he's going to?
Yeah. No, he's going to. He just decided yesterday to go on a trip.
So Mama was going to.
She's not. No, she said no. She's not. She's not going to do it. No, she's not. But Beto, hashtag Beto. We drove through El Paso over break. We stayed in El Paso. I was like looking for Beto. I couldn't find him, but he was there. I feel it. Okay. Couple of things. All right. We're starting a new quarter, new semester. All right. If you look down at your desk, you should have a packet. Put your name at the top. All right. If you haven't, put your name on it. This is going to be due on Thursday. All right. So due Thursday. On Thursday, we're going to take a quiz. All right. Thursday, we're going to take a quiz over the material we cover today, tomorrow, and Thursday. Okay? Now, the goal is to do 3/4 of this packet in class. All right? So I don't want you to freak out too much. But there will be at least one page that we don't get to cover in class that you'll be asked to do outside of class. All right? I'll be checking for the whole packet to be complete for Thursday. Any questions on that? All right. Excellent. So let's talk about random variables. This is from chapter 16. If you want to look at the textbook, whether you have a hard copy or online, this is from chapter 16. So, first off, let's talk about what a random variable means, what it is. All right? So we're going to be using some letters that you used before in algebra class, but they're going to mean different things. All right? We're going to use a capital letter like X. We'll use X today to keep you guys feeling comfortable. It's a familiar letter in math. And that's going to denote a random variable, all right, which assumes any value based on some outcome of a random event. Now, believe it or not, you actually have been experiencing random variables for a long time without really thinking about it. And these two examples I put at the bottom of the slide are going to mean a lot to you very soon when you go to college. All right, I have not been in college in a long time, but I assume it's very similar and it's expensive. And especially books. You're going to be so surprised how expensive a book is. Right? Really, this thing? So I'm hoping when you get to college, a lot of your teachers start to do electronic PDF, something where it saves you a little bit of money. All right? So for discrete random variables, that's where it takes a definite amount, like credit hours. All right? 15 credit hours, 12 credit hours, 18 credit hours. All right? Those are numbers that because there's not any values in between there, like you can't take 15.67 hours, okay? You can't do that, so that's why it's called a discrete random variable. Continuous, on the other hand, is when it can take any range of values, all right? So that's why I put the cost of books for a semester, because that can take any values, all right? $182.33 is a possible value for your books for the semester. It'll probably be more like $750. All right, I know, it's craziness. It's craziness. I remember my Calculus 1 book was $185. Huh? Absolutely, I used it all the time. All right, but after that first semester, I started buying the used books every time. Because I didn't care if somebody highlighted it, underlined stuff. I wanted it to be cheaper. So, I'm sorry?
If they highlighted it, you would know.
If I trust them. You're going to trust some random person that you don't know highlighting? That's a lot of faith there,
I
Jalen.
got a book last time and it was underlined and I had to memorize it.
Oh, so there you go. Well, what if it was Aiden, though? Sorry, Aiden. Come to school. All right. Let's keep going. Now, we're going to spend this week talking about probability models. All right? You're going to notice that the work that we do is going to be a little similar to what we did at the very beginning of this course, so in about September, when we found means, we found standard deviations. But because we're talking about data that isn't actually data, it's made up, or it's going to happen in the future, we call it a model. All right, so this is not they're not telling us what has happened. We need to predict what we think is going to happen. So that's why it's a model. Okay, so you'll be hearing a lot about probability models. And with probability models, we want to find the mean, or the center, and the standard deviation. So we're going to find both today. All right, you're going to need a calculator, and it looks like the calculators have not made it back from the exam, so you're going to need your phone today. But I will try to find calculators before tomorrow. Okay, now you should notice, hopefully, you should notice down here at the bottom in this formula, you see this symbol. Does anybody remember what that symbol is? It's mu. Very good. Guys, I was going to be so sad, but thank you so much. What does mu mean? It's the mean. I gave you the answer. Mean. Right, tough crowd. Okay. All right, 2019, tough crowd. So you'll notice I have not up there, there's no mention of this. Do you remember this symbol? Do you remember Y? That's not Y hat. That's Y bar, which also means the mean. But we use this when it's actual data. Exactly. Is that happening today? No. So you'll notice we're not going to use that. Okay? Don't use that. So the acceptable ones are mu or this one here. The E with the parentheses and your capital X. That means the expected value for your random variable X. Both are acceptable. All right? If I see Y bar this week, I'm going to be disappointed. So no Y bar this week. Pretty good? Okay. We'll talk about what this formula means when we actually do an example. That looks more complicated than it actually is. Let's talk about the standard deviation. Okay? Now, in this chapter, we're actually going to find the variance first, every time. Now, the variance is just the standard deviation squared. Okay? The reason we use standard deviation is we don't want to use squared units. If I told you the variance of something was 108 squared dollars, does squared dollars mean anything to you? No, right? You want just dollars. That makes sense in your brain, talking about money. So that's why we always go to the standard deviation. But I want you guys to focus on first finding the variance. So you should see this symbol, and it's raised to the second power. But what is this symbol called? Sigma! Woo! I love it. We're on fire. I love it. Sigma. And that stands for the standard deviation. Okay? That's the standard deviation. When you square it, we call it the variance. I'll show you how to calculate this by hand. I'm hoping that the yellow calculators can do this for you, so you don't have to do it by hand. But if you do have to do it by hand, it's not a big, long process. So we'll be okay this week. All right, and you'll notice the standard deviation is the square root of that variance. All right, so there's lots of different notations here. It's going to take a few days, hopefully, to get comfortable with using the variance of your random variable x, the standard deviation of your random variable x. But notice, I'm trying to tell you, will you ever see the letter S for standard deviation? No, because that means it's for, when would I use the letter S for standard deviation? When it's from real data. We don't have real data this week, okay? So I don't want to see the letter S for standard deviation. But I'm okay with this here, the capital SD, that's fine. All right? That's okay. All right. How are we doing so far? Everyone okay? Okay, now, I'm going to bring you back to the first unit we ever did. All right? And this was on the midterm. Okay? If you think back to actual data, all right, let's think back if you guys all took your grades for the midterm. Are you thinking about your grade for the midterm? Someone's like, I don't know, I didn't check. All right, think about your grade for your midterm. All right. Now, if I think about the average grade for all of you guys in this class, does everyone have it in their brain? Doesn't matter what it is, right? Okay. Now I decide to take all of your scores and add 10 points to every one of your scores. What happens to the mean? It goes up by 10. All right? We talked about this in the first semester. Now let's think about the standard deviation. The standard deviation doesn't change. How do you change the standard deviation? Not adding, because adding didn't change it. By multiplying. So multiplying and dividing are going to change your measures of spread. All right, in this case, our variance and standard deviation. All right, adding and subtracting only affects the mean. All right, that's what this is saying down here. All right, there's a lot of stuff down here that you're going to read, but this bottom half of this slide here is trying to make you think about what we talked about in the first semester. All right? So when we do an example, I'm going to be talking a lot about, okay, what are they asking you to do? Does that affect just the mean, or does it affect both the mean and the standard deviation? Okay? All right. Questions so far? All right. All right. Now, last slide. This is going to be the phrase or words that I say the most often this week and going forward. A lot of the stuff that we do in the next chapter and then in the units to come all the way until you graduate are based on this idea that variances add. Okay? This is going to be a little counterintuitive, so I have some examples that I'll share with you that have helped in the past. I'll post some videos that I've used in the past to help you explain why we're always going to add variances. When you look at the first two up here about the mean, if I want to add or subtract two different independent random variables, then I'm just going to add or subtract their means. That most students get that pretty quickly when we do an example. The hard part is what to do when you add or subtract the standard deviations. And the thing is, students just want to add or subtract the standard deviations. Don't do it. Always work with variances. Okay? Always work with variances, which is why we're going to calculate the variance first to get you working with variances. All right? So whether you're adding or subtracting two independent random events, you're always going to add the variances every time. All right? I guarantee you this will be on the final. Guaranteed. All right. You guys ready to try one? Yeah? Okay. Make sure you have your phone ready because we are going to use your phone to calculate some stuff. Now, you're going to feel like the rest of this class is turning into a gambling class. It isn't. I'm not promoting gambling. I never have, never will. All right? So don't think that you're learning how to gamble. That's not what this is about. All right. I just have to say that so people hear it, okay? All right. Did anybody play any board games over break? Yeah, you played board games? What'd you play?
Board games and the
Board games, like it has to be like a board. Board game?
Monopoly.
Did you play Monopoly? That's awesome. I love Monopoly. And in Monopoly, you have to roll some dice, right? Does everyone know about a dice? Yeah, 6 sides, 1 through 6. Yeah. Okay. I always bring it up because every year I'm worried that no one remembers what dice are now. Right? It's just Fortnite. Okay, so the way this game works is you roll a dice, and depending on what comes up, you're going to get points. Okay? So I'm going to write down points. So the first thing it tells me is that if I get a 1, a 2, or a 3, that I'm going to get 0 points. All right? So points, 0 points. Now let's think about this. If there are 6 sides and I get 0 points for a 1, a 2, or a 3, then what is going to be the likelihood of me getting 0 points? 3 out of 6. Very good. Now, someone out there is thinking, oh, I can reduce that. That's fine if you'd like to. I don't care. But 3 out of 6 is correct. All right. What's the next number of points I could receive? 5 points. And that's for a 4 or a 5. So what's going to be my probability of getting 5 points? 2 out of 6. And again, if you'd like to, simplify, that's fine. And finally, 50 points. Woo! Well, that's just for getting a 6. What's the likelihood of getting a 6? 1 out of 6. Very good. Now, we're going to find 2 things with this model. All right? This probability model is going to have an expected value, and it's going to have a standard deviation. Now, to find the expected value, we take the possibilities in terms of our points here, 0, 5, and 50, and we're going to multiply them by their respective likelihoods or probabilities. All right, so what is 0 times 3/6? 0. What is 5 times 2/6? 10 over 6? Calculator time? $1.67. Obviously, it's really 6 repeating, but we'll round. And then what about 50 times 1/6? 3 repeating. Now, what you do at this point is you take those numbers on the right, 0, 1.67, and 8.3 repeating, and you add them together. What do you get when you add those three numbers? You should get 10. You might get 9.999, but you get 10. Okay? So I'm going to write this down. Again, here are the options for your notation. You guys ready for the notation? Here are your options. You could write mu equals 10, or you could write the expected value of our random variable x. Either one of these notations is fine. Now, this is interesting, all right? And I hope you find it interesting as well. What's the chance I play this game and get 10 points? If I play the game one time, what's the likelihood I get 10 points? You can't get it. 0. Do you see how my options are 0, 5, or 50? But they're telling me I expect to win 10 points when I play the game. How does that work? How can you expect me to get 10 points if I can't get 10 points? Do you know what this thought requires? You ready for this? I don't think you're ready for this. You ready for this? The law of large numbers. Now, what this means is, it doesn't mean that you expect in one game to win 10 points, because we just said you can't win 10 points if you play it once. What if I play it 10 times, 100 times, 1,000 times, 100,000 times, 1,000,000 times? Then they expect me to earn 10 points. Okay? That's what it means. Any questions on finding the expected value? Are we good? Now, let's find the standard deviation. I told you guys when we find the standard deviation, we're always going to work with finding the variance. Now, here's how you find the variance. What is the first amount of points that I could earn that was in our kind of pseudo table up there? 0. Okay, so you're going to write down in parentheses 0 minus what is the expected value? 10. Now, it's been a while, but anytime we subtract this, it's called a deviation from the mean, your actual value minus your mean, we want to square it. Do you remember why we square it? What happens when you do 0 minus 10? What do you get? A negative. What's going to happen when I get 50 minus 10? A positive. What happens when you add positive and negatives together? They start to cancel each other out. So that's why we square, to make everything positive. Okay? Now, this is what we did last semester. We did this one time. It's been a long time. You probably don't remember. But this is new this year, in 2019. And we have a probability. This is a probability model. So I need to multiply that times the likelihood I get 0. And how often am I going to get 0? 3 out of 6 times. Everybody good so far on where all those numbers came from? Plus. Let's do it for the next one. The next one says you could get 5 points. Minus, what's the expected value? 10. What do I have to do with that deviation? Square it times 2/6. Very good. plus, yes, I'm sorry, you said it. Okay, no, you're good. The last one, plus, what's the last one? 50 minus 10, that's a deviation, square it, times the likelihood, 1 over 6. Whatever all that is, that's called our variance. So you need to take out your calculator. What I would do if I was using my phone calculator is I would find 3 numbers, one for each kind of set of these. So 0 minus 10, we can do that. What's 0 minus 10? Negative 10, square it. Square it. I'm doing the first one. 100. And then what's 100 times 3/6? 50, very good. So that first number is going to be 50. Show you a different color. Yep. Color. So that becomes 50. What about 5 minus 10? That's negative 5. Square it. 25 times 2/6, or 1/3. What's 25 divided by 3? No. 8.3 repeating, yeah. Okay, and the last one. This is going to be a bigger number. What's 50 minus 10? 40 squared. What is that? 40 squared? Okay, 1600 divided by 6. That one I don't know in my head. What was it? 266.6. You're good. Did you square it? You probably just did 40 divided by 6. All right, what happens when you add all those together? I think you get 325. Now, let's see if you know this. What are the units for this 325? I gotcha. It's not points. You're close. It's not points. Squared points. Because what did we do to the deviations? We squared them. So right now, we're saying the variance is 325 squared points. Do I want to deal with squared points? No. What do I want? I want points. So to get rid of that square, what do I do? A square root. And what happens when I take the square root of the variance? What am I writing down? Very good. Sylvester, I'm writing down the standard deviation, or sigma. Well done. All right. So the standard deviation of my random variable x is equal to the square root of 325. All right. What is the square root of 325? 18.03. And what are the units here? Points. Yay. No longer squared points. Okay, let's pause. How do we feel? How are we doing? How's everyone doing? Oh, man, first day back. We haven't do this much work. Whew. Okay, everybody good? Yes. Oh, you could write sigma too. It's the same. You're good. It's like up here, it's mu, or the expected value of x, standard deviation of your random variable x, or sigma, whichever one. Okay, don't care. As long as I don't see what letters. S, and for the mean, the y bar. I don't want to see those this week. Okay, I don't want to see those. These are probability models. Okay, let's keep going with this problem. We're not done, I know. It's going to get even more fun. Imagine that instead of doing 0, 5, and 50 for our points, we double them. So now what's that table look like? 0, 10, and 100. Now let's think about this. Doubling. What are we doing when we double something? What's that operation? Multiplying by by 2. All right, so what am I going to do to my expected value of 10? Multiply it by 2. I love it. So my new expected value is going to be 2 times that random variable, because we're doubling it. All right, so what is 2 times 10? 2 times 10. You're good.
Mr. Patrick,
Yes.
can I say something? Like,
Yeah, sure. Right? This is college. Okay. Any questions on this? On how to get the new expected value? Most students think, okay, that seems pretty straightforward. You double it. Cool. Now here's where it gets a little tricky. All right. I'm actually going to refer to the front side of your notes if you want to flip back to this slide. This is the 4th slide. At the bottom here. Doubling or multiplying by 2 is multiplying each value of a random variable by a constant. We just did this one here. We multiplied 2 times the random variable. What does it want me to do with the variance? If this a is 2, what does it want me to do here? Square it. So instead of taking my variance and multiplying it by 2, what am I actually going to multiply it by? 4. Very good, Jalen, because 2 squared is 4. So this is going to be a little different. So to write this, I'm going to write the variance of doubling my random variable is actually going to be 4 times. And what was my variance? What was my variance that you calculated on the previous page? My variance. Listen to the word I'm saying, the variance. What was it? 325. Very good. You'll notice I'm always dealing in variances. I know ultimately I'm going to find a standard deviation, but what am I doing all my math in? Variances, variances, variances. Focus on that. So what's 4 times 325? 1,400? 1,300? I'll be. Oh, yeah! 1,300. What's the units for variance? Very good. We're starting to get this. Ooh, what do you think of this one? Points squared? What do you guys think? Like that? Points squared? No? So to find the standard deviation, wow, you'd think I've done this before. I'm going to lose all my subscribers. The standard deviation of doubling our random variable is going to be the square root of 1,300. And again, I do not know the square root of 1,300, so you'll have to help me out here, please. Anyone? The square root of, yeah, you got to turn it on the side, I know, right? The iPhone. 36.06 units. Points. Now, I want to be honest with you, because somebody out there just noticed this. What did the new standard deviation become? 36.06. What was the first standard deviation we calculated? 18.03. And what's 18.03 times 2? Now, bro, don't bro me on the first day back. The reason that we did that, bro, is because I want you to get used to working with variances. Okay? I know you thought, well, that seems like we could have just done it a lot faster. We could have. But I want you to get used to working with variances. So that's why. All right, because it's going to pay off right now. Let's do the next one. Imagine we play the game twice. And what a day that would be. We play it twice. Okay? So now we have the expected value of playing it the first time. So I put a subscript with a 1. That's the first time I play it. And what happens when I play it again? What am I going to do to my points? I'm going to add them. So what's the expected value when I play it the first time? What's the expected value when I play it the second time? Also 10. So when I add them together, I get 20. Amazing. Now, what we just did and what we're about to do makes a very large assumption about this game. Does anyone know what assumption we're making when we just add 10 and 10 and get 20? Say it again. It's not being doubled. I don't want you to think it's being doubled. Don't double it. I am asking, but that answer is the answer to the question on the previous slide. When we doubled it, right? We're not doubling it. I know it looks like the same answer, but we're not doubling it. Not actually bad. Yeah. Okay, Jace just said you're assuming you're getting the same thing on the second try. Am I assuming that I'm getting the same roll of the dice? No, right? Because I could have gotten a 0, I could have gotten 5 points or 50 points, could have rolled like a 1 or a 4. I'm not assuming that I get the same number, right? What am I assuming about playing it? Picking up the dice, shaking it, and rolling it again? What am I assuming about those events? I'm assuming that they're independent. That whatever I get on the first one, does that affect what happens on my second game? No. And if we look at a regular standard die, do we feel good about these being independent? Absolutely. Right? As long as we don't think it's rigged, we feel good about it. Okay? Now here we go. We just added the expected values and got 20. So when I find the new standard deviation, what do you think students do that is incorrect? What do they do that's wrong? Let's think about this. What does a student do? Not you guys, right? You're not going to do this. What does a student do that's incorrect? They add 2 standard deviations together. Very good, Jalen. They take 18.03 and add another 18.03, right? Because standard deviation 1 plus standard deviation 2 gives you your answer. And I told you, right at the end of the lecture, the most important thing to take away from this class are 2 words. Variances, add. So we're not going to add the standard deviations. We're going to add the variances. Okay, so what was the variance for playing the game? 325 squared points, right? And we're going to add 325 to get 650. And what are the units? Squared points. Now, is that what I want? Is that what the problem asks for? No, the problem asks for the standard deviation. To find the standard deviation, what do you do to the variance? Take the square root, and we're done. So the square root of 650. What is the square root of 650? $25.5? Can you go one more? 25.4 or something? Ooh, what's after the 9? Okay, so 25.50 it is. Thank you. And the units? Points. Now, do you see? I hope that you see as you're writing this down. You may not yet, that's okay. But I hope some of you out there see how easy this is to fall into this trap. It makes sense, right? You take your standard deviation of your first game, add it to the standard deviation of your second game. 18 plus 18 is 36. Was that our answer? No. So that's why you have to focus on variances, add. All right, one more. Then we'll move into something different, okay? One more. Now you and a friend get to play. Man, this is turning out to be the best day. All right? You and your best, think of your best friend. Your best friend. Okay? My dog. Oh, I miss her. I mean my wife. Sorry about that. So, you and your best friend play the game. But instead of adding your point totals together, it wants us to do what? Find the difference, which is another word for subtraction. So now the expected value is not going to be adding them together, but it's going to be subtracting them. So what's the expected value of points that I am going to get when I play? 10. What's the expected value for my best friend? Also 10. When I subtract 10 minus 10, I get 0. So we're expecting our difference to be 0 points. Everybody feel good about that? That's most students say, yeah, that makes sense. All right, just subtract. Now, you ready for this? I don't think you are ready for this. We're subtracting. Well, what are we going to do to find the standard deviation? Add the variances. So we have our answer already. It's 25.50. I know, right? Right? Isn't that magical? We're done. We don't need to do the work again. We already added the variances. We got 650, took the square root, got 25.50 points.
But even when it asks for differences, you still add the variance.
I love it. See, you're getting it. Right? If you look inside right here on your arm, you'll see variances add, tattooed right there. Variances add. Variances add. I hope you guys enjoyed the first video of 2019. Don't forget, like, subscribe, comment. Hit me up with any stats questions. We out.